You guys could probably do a better job than me anyway, but whatever. Thank you.
Okay, all right, so they give us some examples of permutations on the next page. So remember what's a permutation again? Order matters. All right, so the first one says, list the permutations of the three letters M, N, O. So it's all the ways you could mix those up. So I know you could do this without me, but I'm gonna go ahead and do it just so the video doesn't run too long. So obviously M, N, O. What else could you do? So like you could just start listing them any way you want. I like to do it strategically so I don't lose like my place or what's going on. So I'm gonna keep the M in front and I'm gonna switch the O in the end. Everybody cool? Okay. Those are all the ways with M in front. Now I'm gonna switch it up and put N in front, maybe N-O-M. No. And then N-M-O. And then, what else could you do? O-M-N or O-N-M. Those are all the ways you could rearrange, right? So how many are there? There's 6. What if it had said combination? Bless you. So remember, combination order doesn't matter. How many combinations are there? There's not 6. Permutation, when you change the order of the letters, it matters. So there's 6. But what if changing the order doesn't make any difference for a combination? It's just the same 3 letters, so it doesn't change. It doesn't matter. So what would it be? It would be 1. That's the difference. Everybody got it? They don't care about the order, so a combination would just be 1. Okay. I'm going to show you a way to think through this where you don't have to write down. Like that's our sample space. So the same question, we have 3 letters. We have to use all 3, right? So I'm going to do the spaces like I did with the pants and the shirt. So the very first letter we have to choose from, we have to pick M, N, or O. So how many choices are there? 3. Now we had to pick a letter. How many are left for the next letter? 2. We picked that one. How many are left for the last letter? 1. So 3 times 2 times 1 is, guess what? 6. So that's why we had 6 in our sample space. Okay. All right, next one. How many ways are there to see 8 people around a table, right? So anytime you switch any person, it changes it. So we don't have to list them all because there's a lot of them. But let's do it the same way. 8 people, so I'm going to put 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 seats for 8 people. All right, we're going to put the first person in a chair. How many people do we have to choose from? 8. Okay, that person sits down. How many do we have left? 7. That person sits down. 6, 5, 4, 3, 2, 1. Ooh. You guys remember what that's called? It is a pattern, but we have a function that we learned first semester that tells you it's the exclamation mark. It's 8 factorial. Everybody say factorial. You remember using it for like the binomial theorem? We did it first semester. Guess what? You guys have a factorial button on your calculators, so get out your calculators. So, on the school calculators, I think it's under, somebody have a school calculator? I think it's under the 9 key, is that right? Oh, no, it's not. The factorial button is under the 3. So you would use 8, and then second, and then 3. Some calculators, the factorial is hidden under a button that says PRB for probability. So if you click on that, there's usually a factorial button under there. If you can't find it, raise your hand up. Yeah, you have a period. So you should get, what is it, 40,000? 40,000. That's a lot, huh? A lot of ways to sit down. A lot of musical chairs. Okay. All right. I want you guys to figure out the next one. How many ways can 4 runners place in first, second, third, and fourth? All right, what do you guys think? 24 is correct. Guess why? Right, how many do you have to choose? How many runners for the first place? 4, 3, 2, 1. Which is 4 factorial, right? So it's 24. Everybody good? You can't. You have to give it, right? You gotta go take it that last spot. Don't be lazy. Don't be lazy. All right, how about the next one? How many ways can you permutate 5 objects? You don't know what they are, don't know, don't care. So what is it? 5 factorial. So go ahead, what's 5 factorial? 120. All right. How about the next one? How many ways can clown be arranged? It's still 120, because do we care what the things are? Still 5 things, so it's still 5 factorial. So it's still 120, right? Okay, so it says right here, if you're doing a permutation where order matters, and you have n distinct, so they have to be different, okay? N distinct objects, it's always gonna be n factorial. So if it was 5 objects, 5 factorial. If it's 8 objects, it's 8 factorial. Right? Okay, so then they throw a curveball at us. How many ways can the letters in Mississippi be arranged? So Mississippi is a long word. How many letters is that, Alex? 11. So we agree that there's 11 factorial. The issue, what's wrong? What's not? It's not wrong, but what's different about the word Mississippi? Some of the letters repeat, and so that's not distinct. Does that make sense? So if you think about it, let's just take the I's. If you switch any of the I's, does it actually change? It doesn't change. So those are being counted extra. Same thing with the S's and same thing with the P's. So there's a lot of extras being counted in 11 factorial that need to be divided out. So we have to divide out repeaters. We're going to divide out repeaters. So here's how we do that. So let's take the letter I. How many I's are there? There's 4 I's. So no matter how I take those 4 I's and I switch them around, it's all going to be the same. So that's not just 4, it's 4 factorial, isn't it? Because it's 4 things that are the same, switching around. All right. How about the S? How many S's are there? 4. So that's another 4 factorial that has to be divided out. And P's, how many P's are there? All right, so give it a try. Can you do that on your calculator? guys have to tell me if you have a pause at the beginning of the period, not in the middle of my lesson. Did you guys get it? Did you get it? Because knowing how to use your calculator is important, right? Otherwise, it's just a weapon of math destruction. All right, my favorite question is the next one because it's talking about ice cream. All right, how many different ice cream cones could you have? You're gonna get a double scoop. So I'm gonna draw a picture. There's my cone. Double cone, right? Best picture I've drawn all year. Although it's kind of boring, we only can choose from chocolate, strawberry, vanilla. And we're assuming that you get different flavors for each scoop, which not everybody always does that. If I'm getting ice cream, I actually only get chocolate chip. So I'd get 2 scoops of chocolate chip. But if I go to Newbies and I'm getting frozen yogurt, which we do a lot, because my boys and I like it. It makes a difference to me what ice cream you put on what kind of ice cream. Is anybody else like that if you're getting 2 different scoops? So I always at Newbies get chocolate and I get pomegranate. That the pomegranate has to go on top of the chocolate, because if the chocolate goes on top of the pomegranate, it mixes up and then it tastes different, right? So I'm picky about that. So we're gonna assume this is the same way. Order matters, okay? The order that we put it up matters. So, what do you guys think? How many ways? How many ways are there to pick this bottom scoop? Aren't there chocolate, strawberry, or vanilla? So there's 3, right? 3 ways. Now how many are left for the top scoop? There's 2. So 3 times 2 is, it's okay. 3 times 2 is 6. Everybody good? Okay.
Next page.